Okay, let's dive into this. This explainer is part of a public prior art sequence for OpenLine Protocol by Terrence White. We're starting with a simple, but honestly a pretty pervasive problem right now in the world of autonomous AI. Here's the deal. A system can very easily produce a perfectly signed, cryptographically secure receipt for a completely bad agent run. We've all been taught that a digital signature means a record is rock solid and trustworthy, right? Well, when it comes to AI agents acting on our behalf, relying on that assumption is incredibly dangerous.
To see why, let's ground this highly technical topic in a really relatable everyday example. Say you've got an AI agent, and you hand it a totally ordinary task, like book my weekend travel to Austin. The agent goes out, pings the booking APIs, spends your money, and boom! It emits a real receipt, it dings happily. The job is technically completed, and you've got the authenticated record right there to prove it did the work.
And this brilliantly illustrates the trap. You open your email and realize it booked a non-refundable room in Boston, not Austin. Your receipt is totally real. The task technically completed successfully. But the actual result? It was expensive, it was brittle, it was just plain wrong, and now it's going to require hours of human cleanup to fix the mess. A perfectly signed receipt can still document a terrible, highly expensive outcome. Which brings us to this exact foundational rule you absolutely need to remember. Cryptography proves custody. It does not prove coherence. Think about it. A signature proves who created the record and guarantees that the record wasn't tampered with after the fact. That is custody. But it proves literally nothing about whether the agent actually did good work, or held its reasoning together, or achieved anything useful. That's coherence. So to clear up the confusion around where actual accountability and evaluation are supposed to happen, we have to cleanly chop the AI stack into 3 distinct layers. First, you have a log, and that stays inside the platform. Think of that as the vendor's private diary. Second, a receipt travels across the trust boundary. That's the portable proof object you actually get to hold in your hands. Third, a selector decides which of those receipts actually deserve routing, reputation, and market weight moving forward.
Let's define the specific tools working at these layers. The OpenLine protocol acts as that portable receipt layer. It's the thing providing the proof object, the cryptographic record that can actually leave the platform and travel around with you. But as we just saw with our disastrous hotel booking, having the receipt alone simply isn't enough to guarantee the system is doing its job well.
That is exactly why we need the third layer, COL, which is built on coherence dynamics. This is the proposed selector layer that provides the triage mechanism to actually read and make sense of those receipts. Now, I want to be super clear here. We are not presenting the underlying math of this layer as universally validated just yet. It is the proposed control logic used to evaluate the behavior that's recorded in the receipt.
And the guiding philosophy of that selector layer is triage, not truth. We aren't out here trying to establish some absolute objective truth about the universe. The whole goal here is to quickly find the breakdown, figure out exactly where the workflow went off the rails, and evaluate how reliable the system is when you put it under pressure.
So how does the selector actually measure that? Well, we can translate all those complex equations into plain English using this visual ladder. First step, stress gets attention. A kappa spike can show us that something changed, broke, or surprised the system, creating a strain. But a spike alone isn't an insight, right? Second, coherence has to survive that stress. Variables like phi star and VKD basically ask, did the system hold together after getting shoved, or did it just throw a tantrum and make noise? Third, metrics like epsilon and recovery time ask if the system actually learned to recover cheaper across repeated exposures. And fourth, if it does those things, provisional trust increases.
Listen closely to this because it's key. The shove is not the insight. The shove plus clean recovery is the insight. That is how an AI agent actually earns provisional trust from us. It's not about an agent magically never experiencing stress or making errors. It's about whether the system held its act together after it got shoved and whether it learned to recover cheaper the next time, instead of just producing one dramatic, expensive episode after another.
If we don't build this selector layer in, we are looking at a massive problem. A receipt network without selectors just becomes a landfill of signed noise. Think about it for a second. Agents operate at machine speed. They could easily pump out thousands of authenticated, perfectly signed records every single minute that tell us absolutely nothing about whether that particular pathway should actually be repeated.
Let's move to, and see how this builds incredible value for developers, because this isn't just theory. Selectors are what actually empower you to actively manage these autonomous agents. Instead of just blindly trusting whatever the platform claims, you can actively compare runs, you can reject those costly retry loops before they completely drain your budget, route the work to better models or tools,
and build a real reputation around verified selected performance.
This completely shifts the focus for the markets, too. If receipts are ever going to become real, usable market inputs, we have to look way past the cryptography and start asking plain, practical questions. Beyond just asking, hey, was this signed? The very first market question is, did the reasoning stay stable when the pressure was on?
Did the run drift? When the agent hit a little bit of friction, did it completely lose its path and go off on some wild tangent, or did it stay locked on to the actual goal we assigned it?
Did unsupported claims increase? In other words, when the system got pushed or a little confused, did it just start making up noise and hallucinating to fill in the blanks?
Now, what's really interesting about this slide is the adaptation aspect. Did recovery actually improve over repeated attempts? We're essentially asking if the system actually learned from the exposure, or if it's going to burn through the exact same amount of expensive compute and time every single time it faces that specific hurdle.
And then, the ultimate market question to wrap that up. Was the outcome actually worth the cost in the human repair? This right here highlights the massive hidden maintenance tax of AI. Just relying on the fact that a task was technically completed totally masks the reality of how much money, token spend, and manual human cleanup it took to drag it across the finish line.
Okay, we have to address the elephant in the room, big tech. Look, large companies can absolutely copy the signed receipt format. They can copy the fancy dashboards, and they can copy the metadata. But there is a fundamental structural difference between a big tech silo and a neutral layer. Because a vendor grading its own receipt, even a cryptographically secure one, still has a massive, glaring credibility problem. Because as the protocol's foundation clearly states, they can copy the object, they cannot unilaterally manufacture neutrality. Your selector logic simply cannot depend on trusting the very platform whose agent just acted. True real-world accountability requires open receipts, public conformance, and independent verification completely outside of the vendor's walled garden.
So the crucial point is that we are not making some mystical claim about having perfectly solved autonomous intelligence or alignment here. OpenLine proposes the proof object, and Cole proposes the triage layer. It's a grounded engineering mechanism, and the whole thing is held accountable by the falsifier. If these selector signals do not predict better outcomes than simpler checks, then the selector needs to be demoted or redesigned. It requires rigorous backtesting, pilots, and falsification to actually prove it works. I want to close our explainer today by leaving you with this exact, critical thought on why we absolutely have to go beyond just logging AI actions. A signed receipt can prove a record exists. It cannot prove the run deserved trust. That is why OpenLine needs more than receipts. It needs a way to tell learning from drama. Proof moves, data doesn't.